Hello. In this video, I am going to go over the final project and the different the processes of getting the results for the final project. So for the task of the final project, I was assigned to test for the bacteria H. influenzae in children with otitis media in the Northern Territory of Australia. The response variable would be the yes or no of the bacteria presence, which it was coded as Y or N in the actual data. The independent variables are active and placebo group, which are coded as A or P. The active high-low levels of compliance, which are coded as a high and low in the actual data file, and the weak number of the test, which is a numeric value, the ID, which records the grouping of the test subjects, and TRT, which combines the active or placebo group with the high and low metrics. So it combines it into a group with three parts, which is called placebo, drug, and drug plus, which drug plus corresponds to the high level of compliance and the low level of compliance in taking the drug. The drug is just the low compliance. So the objectives for this project, therefore, would be to evaluate the effectiveness of the drug treatments on the bacteria. And in addition, there is also a weak number, so I would figure out that it would be beneficial to evaluate the time frame of the drug effectiveness. So this is we are going to first, what I did was to examine the overall proportions of the data. So based on the binary outcome, uses the because of the binary outcome, we are going to use the binomial GOM with the largest function, and we are going to have a different outcome proportions between the different treatment groups, which we are going to check for significance. As you can see in the outcome proportion plot, there is the placebo group has the most subjects here, and the drug with the low compliance group has has a certain amount of subjects here as well, but it's lower than the placebo group, and the drug with the high compliance is also it's around the same has this around the same subjects as the drug as the low compliance group. However, there is a bit of a proportional difference in the outcomes. So the proportions for the drug group is much higher, I'd say, for the outcomes. So than the placebo groups comparatively. However, the drug groups between the high and low compliance groups, those tend to have around the same proportion of outcomes. So we are going to test for these. And then I moved on to the weak number plot and versus a time and versus a negative rate. So I would like to see how the time affects the data. And it seems that the placebo group, the data is increasing overall, and however, it does not, the bacteria negative rate does not rise as high as the two treatment groups, which are here. So I would then like to do a model structure selection now that we've got the overall objectives of the research. So the research is so we are going to answer the AP plus high-low or TRT. because TRT is a combination of AP and high-low, it will be a collinear aspect, so they cannot be used together. So the question is to whether I should use AP or high-low or TRT. So the main idea is that AP plus high-low is also a so TRT does not account for the high-low compliance in the placebo group. So I made a time plot for that as well. And it seems that there is a significant difference between the high-low and placebo group, and that may not be captured in just by using the TRT. So I chose to use AP plus high-low as the input with and also I would like to use some influences to test if there are influences between the high-low and the drug application group, the treatment application group. And the relatively few weak number labels. So you have over here, we have weak numbers of data collection, for example. And so it is relatively few. There's only like week 1, week 2, week 3, week 5, and week 11. So we could indeed use a factor to compare the significance of each week. So the family, as I said before, is a binomial family because there is only 2 outcomes. And we would like to randomize ID to determine the grouping effects. And so I have came up with the following model formula initially for the first round of comparison. So the model would be so AP plus high-low plus the influence group plus a factor of weak. So for the model diagnostics, the significance with influence and randomized on ID, and there is no influence between the active placebo versus the compliance group, as you can see based on the fixed effects. So significant. So this is the significance table, and as you can see, there is almost no significance at all, pretty much in the Wald test for the influence term. And there is already, we can see there are for the different weak factors starting from week 4, there is it becomes significant that the drug is taking the progression of time is taking an effect on the outcomes. So starting from week 4, the outcomes starts to increase dramatically. That the change in outcomes becomes significant, pretty much. And currently, with the influence term, there is no significance on the placebo, the grouping data, and the compliance. There is none significance here. But however, once the influence is removed, the grouping becomes slightly significant. And however, the high-low compliance is still not significant. So pretty much this is the summarization of the test after the removal of the influence term. So now we're continuing with the model diagnostics. So now since previously we have concluded that the high-low compliance group does not affect the drug effects at all. So, and nor it does not influence the drug. It does not influence the outcome at all as well. So we just remove the high-low compliance factor. And so we're just going to test on the application. The active or placebo application here. And in addition, the weak is still kept because we still have we notice that trend already. So, and we do still, as you can see, though, starting from week 4, 6, 11, so those are becoming significant, which is consistent with the data in the previous section. And in addition, I have done a Cook's distance test at this stage. So there are some extreme influence points that are like in the order. So especially if the influence points greater than 100. So those I will remove for the next model. So I just remove those models, and as you can see here, that it confirms the grouping factor becomes more significant. The z value has dropped to 0.05, which is very becoming significant here. And the factor, the weak is still maintains the same pattern. So I decided to use a numerical weakest variable instead of using a factor instead. So for here, once I did that, it becomes it fell under 0.05, which is a significant, a typical barrier that were used to determine the significance. So we do get here both the test group and the weak become significant as based on it, which is consistent with the previous data. Now we're going to see the diagnostics of the test and the random effects diagnostics. So we do have relatively high. It's not 0 definitely, and we do keep the random effects in the model. For the variance is relatively high. So I also went back to refit the model and use a cutoff to refit the original data. So both used 0.5 cutoff, and it turns out to have 84.5 accuracy for the numerical model. And using the factor model, I get 85.4 accuracy. So they are about the same level of performance. And so the only difference between those models are just what you would like to see with the amount of details you would like to see with the week of the time frame of effectiveness. So at the end, we would like to do some conclusions based on the data. So the drug overall is indeed effective in removing the bacteria compared to the placebo baseline. And the drug effectiveness will increases with time. So at the beginning, and usually it doesn't wait. And at week 4, the effectiveness increases dramatically. And using the factors, week 4 marks the beginning of the significant change of effectiveness, which is consistent with the plots that I have shown at the beginning of the slides. And in addition, the different kinds of compliance, so which does not affect the drug's effectiveness. So even if the drugs are not taken on a regular basis, the drug is still as effective in removing the bacteria. And so both taking the weakest factor and numeric, as I have said before, it just yields the same amount of performance. But again, it's only the amount of details that other researchers might like to see that's different between those two models. So thank you, and this hereby concludes my presentation.